Hey, Math 111 students, we're doing section 5.6 now. We're just going to jump right on in. All right, so let's look at our PowerPoint here. We are going today to do the graphs of the sine and the cosine function. The graphs of the sine and the cosine function, we're going to deal with what we call amplitude and period. Amplitude would be the height of the sine and cosine function. Period would be how often it repeats itself. All right, so let's think about this a little bit. We've got these functions here, and so they're new functions where the x value that we plug in will be the angle. And for the various functions, you'll get out the sine of that angle, or the cosine of that angle, or the tangent of that angle. All right, now, here is the first graph, the graph of the sine, but let me go back here to our old handy dandy self-made cheat sheet that you can use now. And I want to tell you what we're doing. All right, this graph right here has our angles. It's the unit circle, so a radius of 1 here. It has all of our angles all the way around, and the points on this graph are the cosine and the sine at that angle. Now we are going to start making new graphs of different functions. This number 1 is not a function at all because it's a circle and it has points that lie on top of each other. So this is not even a function. But now we're going to start making functions where the angle is the x value that you plug in and the y that you get out is either going to be the sine or the cosine at that angle. So now the 0 becomes the x, the y becomes the 0. The 30 degrees or the pi over 6 is the x, the 1/2 is the y, and so forth. That would be for the sine. And then for the cosine function, the degree in radian or degree angle measure is the x. For the cosine function, the 1 would be the y. All right, so we're doing a different type of function. And these types of functions then look more like the Cartesian plane that we are, let's see, yes, I am, that we're used to. Now, let's think about how we're going to do that then. All right, let me go back one more time here to this sheet here. Let's just go ahead and start forming our values first. All right, so here's a sheet of paper I used before. Let's just do our values for the very first quadrant for the sine function. Okay, the sine function. Sine of x. So our function is the f of x equals the sine of x, where the x value I'm plugging in is the angle measure, and the y value I'm getting out is the sine of that angle measure. So I'm going to put in at 0, angle measure of 0, an angle measure of 30 or pi over 6, angle measure of 45 or pi over 4, an angle measure pi over 3. You could do these, but actually we're better off just doing the ones at the 4. So let's do 0, pi over 4, pi over 2, 3 pi over 4, pi, and so forth. Okay, and then we can make our amount at 0. What's the sine of 0? At 0 degrees, the sine of 0 is 0. Okay, we skip pi over 6. At pi over 4, what's the sine at pi over 4? The angle pi over 4, the sine is root 2 over 2. So I'm making a new function. At pi over 2, at the angle pi over 2, what's the sine at pi over 2? At the angle pi over 2, the sine of pi over 2 is 1. Okay, and so forth. Okay, that is how the book here then made this chart. All right, so do you see our chart here? At pi over 2, the sine was 1, and that gives us a new ordered pair, pi over 2, 1. At pi, the sine is 0, gives us a new ordered pair, pi over pi 0. And now we are going to make our x-axis the angles from 0 to 2 pi. So instead of our angles from 0 to 2 pi being in a circle, we've made them out as a straight line that we're counting down. And then the y value becomes the sine at that point. All right, so the sine when at a 0 degree angle measure, the sine at 0 is 0. At the pi over 2, the sine of the pi over 2 was positive 1. When you go all the way around to pi, the sine at pi was 0. When you got around to 3 pi over 2, the sine at 3 pi over 2 was negative 1. And when you got back to 2 pi, the sine at 2 pi was back to 0. And this is what forms what we generally know as a sine curve. Okay, or sine curve. And it extends on. So I'm just doing it between 0 and 2 pi, but you know you can have negative angles over here, and you can go beyond 2 pi to 4 pi, to 6 pi, and so on. So often we will just consider it between 0 and 2 pi, so we'll only consider one revolution around the unit circle, but it could go on infinitely. All right, so showing you there. Properties of the sine function, the domain for the regular, unless we restrict the domain is all real numbers. However, the range of the original sine function only goes up and down to 1. So up to positive 1, down to negative 1. It's an odd function. Okay, so if you look back here at the graph, it's an odd function. In other words, if you take the negative x value, you get a negative y value. So at pi over 2, 1, okay, right here, if we take the negative x value, negative pi over 2, we get the negative y value. It is symmetric across the origin, and that makes it odd. It's periodic. That means it repeats every 2 pi. And I'm not that concerned right now about intercepts, maximums, and minimums. All right, but what if we do transformations on it? So we're going to do transformations. We're going to take our basic sine function, which we just graphed, and we're going to change the amplitude. And then A is the amplitude, and this little symbol that looks like a W is the omega symbol. So what does an A outside of the function and the omega within the input value, how does that change our function? All right, well, let's look at 3 sine x. So that would be the A value. If you multiplied it out here, this is your original sine function, we are going to stretch each y value by a factor of 3. So this is going to pull us up to positive 3 and down to negative 3. That's the amplitude. Okay, and that should make some sense. So instead of being at 1, it's going to pull us up to 1 times 3. Instead of going down to negative 1, it's going to pull us down to negative 1 times 3. This is the amplitude. All right, how about this one? A negative 2. Okay, then that's going to move us up and down to positive 2. What does the negative do? Negative works exactly like it did in Math 110. If you took me for Math 110, you know that the negative outside the front flips it upside down, inverts it. But what does this 2 in here do? All right, let's look at that and explore it for a minute. All right, so here's our original. Okay, we're going to flip it upside down. All right, we still need to pull it up and down. We've only taken care of the negative here. All right, now let's take care of the 2. So let's do our amplitude. That's going to pick it up and down to positive 2 and down to negative 2. What does the 2 inside the x do? That shrinks it. That affects the period. All right, the negative 2 out front affected the amplitude, how high up it goes, how low down it goes. The 2 inside the parentheses by the x compacts it or expands it. In this case, even though you're multiplying it by 2, it actually compacts it by half. All right, so where you did at pi over 2, you had -2. Now you're going to divide that in half. Now that -2 will be at pi over 4. At pi, you were at 0. Now that is going to be at pi over 2. Now at pi over 2, you're at 0. Okay, so we actually divided it or compressed it in half. All right, similar with cosine. All right, if we went around our unit circle, when the degree is 0, the cosine at 0 is 1, and that creates the point 0.01. At the angle pi over 3, the cosine at pi over 3 is 1/2. That creates the new point for the cosine function of pi over 3 1/2. At pi over 2 on our unit circle, the cosine is 0, and that creates the new point pi over 2 0, and so forth. If we graph these on a Cartesian plane, starting at 0 on the x and going through 2 pi. Okay, at 0 on the x, we would graph the point 1. At pi over 2 on the x, we would graph the point 0. At pi on the x, we would go down to -1. At 3 pi over 2, we're back at 0. And at 2 pi, we're at 1. If that's confusing to you, slow me down and back up and go through it 1 or 2 more times. This one has the period from 0 to 2 pi. It limits our domain from 0 to 2 pi, but just like sine, it could go on indefinitely. You'll have negative angle measures and you'll have positive angle measures much beyond 2 pi. All right, and this shows the same one from -infinity to infinity. Now, is it even or odd? Well, look here. All right, this one is even. Okay, and the definition of an even function is that, so if it's even, then the cosine of x will equal the cosine of -x. That's the definition of an even function. And that's true. So if I go from, let's say, pi, okay, at pi, my cosine is -1. Well, at negative pi, it's also -1. That is the definition of an even function. An even function. And the way you look at it is symmetric across the y-axis. So if I flip this around the y-axis, I get the same graph. All right, so the domain of the cosine function is a set of all real numbers. Range goes up to 1, down to -1 for the standard. Again, it's an even function and has a period of 2 pi, period meaning it repeats every 2 pi. All right, same thing with the a out front and the omega with the x. The a is going to raise it up or down. It's the amplitude, and the omega will compact it or expand it left to right. So 2 cosine 3x. Well, the 2 means you're going to go up and down to +2 and -2. All right, what is the 3 inside? Well, just like the 2 with the sine, the 3 is going to compact it by a power of 3. And so instead of being at pi -1, that new value will be pi over 3 -1. It's going to cut it into, let's see if we can get this to, it, you know, they did it on the same scale, which makes it less clear. But now the -2 there is at pi over 3, the +2 is at 0, and the next +2 is at 2 pi over 3. But they didn't do it on the same scale, so you don't see it quite as clearly there. If you graphed them right on top of each other, though, you can see it a little bit more clearly. So the original blue is the original cosine of x, and the orange on top of it is 2 cosine 3x. Now the amplitude, it's going up and down to +2 and -2, and the period is that it starts repeating. Now it repeats every pi over, let's see, instead of every 2 pi, it's going to repeat every 2 pi over 3. So that's pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3. There. Right. All right. Notice here, let me show you real quick, that these are really just, hang on one second. These are really just shifts of one another. So sine of x is the same as cosine of x, just shifted by pi over 2. All righty, so determine the amplitude and period of sinusoidal functions. Here are formulas. The amplitude is just going to be the absolute value of whatever your A value is. The period, though, you have to do a little bit more work. The period is going to be T. That's our letter we use for it. And it equals 2 pi divided by omega. 2 pi divided by omega. Write that down somewhere. All right, so let's do it. What's the amplitude and period for y equals 5 sine x? Well, the amplitude, that's pretty straightforward. That's 5. Okay, amplitude equals 5. Period is, we use the letter T. It is going to be 2 pi divided by the omega. And that's as simplified as it'll get, 2 pi over 3. All right, so let's graph a sinusoidal point using key points. Now, normally it would repeat every 2 pi, right? But what's our new period? Our new period here is going to be 2 pi divided by 2. So now ours is going to repeat every pi. All right. So if I were drawing this guy, pardon my, it's very hard for me to keep this perspective here. All right, but I would start at 0, and now I'm going to have, it'll repeat every pi, and so I'm going to divide it into 4. So pi over 2, pi over 4, and then this would be 3 pi over 4. And my period, excuse me, my amplitude was 2, and so now I'll still start at 0, 0, but here, instead of going up to 1, I'm going to go up to 2. Still be back to, sorry, having a hard time doing my little circles. Back to 0. I'll do little X's. Down to -2, and then back to 0. And we would have a, oh, terrible. I need to do it on graph paper. Terrible trying to draw this by hand using this perspective of drawing on the screen with my pad on the computer. They've got it a little more nicely out for us. All right, so they did it. We realized our period would be 2 pi. We divided it into 4s, and then we found our values. We know that instead of going up to 1 and down to -1, it's going to go up to 2 and down to -2. Our, yeah. And you could extend it on All right, so you got a little summary here, key points for determining for graphing a sinusoidal function, the sine and the cosine, determine the amplitude and the period. Then you can take your period, divide it into 4 equal units, and use your amplitude to decide how high and low you go in those. All right, so what if I give you 4 sine negative pi over 4x? And I'm going to do it over here because that is just way easier. All right, I was given 4 sine negative pi over 4x. Oops, x. Okay, now amplitude is 4. It's a function too. Amplitude is 4, no problem there. Period is going to be t, the letter t is going to be 2 pi divided by the omega. And so let's just do it like this. Divided by the omega, the negative pi over 4. So that would be 2 pi dividing by a fraction is multiplying by the reciprocal. Look, my pi's cancel out. And I'm left with a period of -8. All right, well, that makes it a little bit easier to draw, right? All right, wait a second. The period is -8. Well, that makes no sense, right? That the period is -8. Let's see, I can't see my screen. There we go. All right, right, that didn't make, and so this is where you want to remember that the sign is odd. Sine is odd, cosine is even, sine is odd. So if y equals 4 sine negative pi over 4y, then that means we should rewrite it here. This is going to be y equals, you can bring the negative out front, -4 sine negative pi over 4x, excuse me, positive pi over 4x. All right, this is rewriting this using the principle that it's odd. Remember that the odd says the opposite of this is going to give you the opposite y. But instead of putting the negative out there, we could put it on that side. That's perfectly legal algebraic move. All right, so now if we do it that way, then our period is 8, not -8, and that makes a little more sense. So let's start to graph this guy. All right, we're going to start here. I'm going to let each one be 2. 2, 4, 6, 8. Here's 8. Divided in half, that would be 4, 2, 6. All right, and instead of going up and down to 1, we're going to go now, we're going to flip it upside down and we're going to go up and down to 4. So normally we would start at 0, 0, we'll still start at 0, 0, and at 2, we would say we would be up at +4, but because of the negative now, we're going to be down here at -4. At 4, we're back to 0. At 6, we're up to 4, and at 8, we're back to 0. So if we sketch this guy out, this is how it is between 0 and 8. And then, of course, it would go on infinitely. Our period is 8. Our amplitude is 4. And we've got that in our notes if you need to go back and review it. How about -4 cosine pi over x minus 2? All right, now do you remember from Math 110? What does the -2 outside of it do? That's going to pick it up. and move it up and down the y-axis. So now we have an amplitude of 4, but it's going to be flipped upside down, right? And what is our period going to be here? Well, we need to take our t, find our t. Our t is going to be 2 pi divided by the omega. So our period is just going to be, oh, wait, our omega was indeed pi. Pi's cancel out. We have a period of 2. A period of 2. All right, so let's go back to our thing here. All right, so now we got a period of 2. So let me make a graph, new graph. We are going from 0 to 2, and let's count up, let's see. Let's do, I'll make my 2 here. And then that would make that 1, and this would make this 1/2, and then this would be 1.5, which is 3/2. Okay. All right, Tay. And we were doing cosine this time. This was y equals -4 cosine, excuse me, -4 cosine pi over x, and it was -2. All right, so that's how we got the period of 2. Our period equals 2. All right, we are going to be flipped upside down, and we're going to pick it up and move it upside down. All right, I'm going to graph it first without moving it. So at 0, 0, and no, cosine starts at 1. Cosine starts at 1, but we're going to go up to 4, except we're inversing it. So we're actually going to start at -4, -1, -2, -3, -4. So I'm going to start down there, okay? And then I'll be at 0 here, and then I'm going to go up to 1, 2, 3, 4 here. And then we go back down to 0, and then I'm going to go back down to -4. So before I use my transformation, I'm going to be something like this. This takes into account the negative. It takes into account the 4, and it takes into account the new period, the pi, the omega. What it doesn't yet take into account is moving it down 2. So I need to do one more step here. I will pull out my blue pen, and I've got to move the entire thing down 2. So my final version of this is going to be more like that. Okay. All right. Now, again, this is in your notes. So let's look back at how the PowerPoint shows this. All right. So they get here. That's where we started. But we need to now pick it up and move it down 2. They have not yet moved it down 2. All right, move it down 2 units, and that's your final version. All right, how about, can we go backwards? Can we find the equation given a graph? Well, you can. It's definitely not terrible. Number 1, what's our amplitude here? First of all, this looks like a sine, okay, because you start at 0 and you end at 0. Our period, our t value seems to be 4. Looks like we repeat every 4 units. Our amplitude looks to be 2. We're going up to 2 and down to 2. Does not look flipped, so I don't think we have a negative. All right, so I'm saying this is going to be y equals 2 sine, but what is my omega value? Well, your period, remember, equals 2 pi divided by the omega value. Okay, so 4 equals 2 pi over omega. Now we just need to solve for omega. It's a great time to use the middle school algebraic thing of cross multiplication. So 4 times w equals 2 pi times 1. I say w, I'm sorry. 4 times omega equals 2 pi times 1, which is 2 pi, divide both sides by 4, and we get that the omega equals pi over 2. So this would be y equals 2 sine pi over 2, that's your omega, x. We were not picked up and moved up or down, so that is your equation. Again, I looked at the amplitude. That was obvious. It was pretty clear it was sine. It had not been flipped, so no negative in front of the amplitude, but it was a little work to find the coefficient of the x term there, okay? All right. So with all that said, I think we've got what we need in this section. And you should have what you need now to do your homework for 5.6. As always, you can use the Ask My Instructor button if you get stuck. You can call me at 268-2516 or email me at alsupwh@octech.edu. And your keyword for today is the blue whale. The blue whale, the big mama in the ocean. All right, see you later. Bye.